Hello everyone, welcome to Chapter 2. This is the first part of that, and in this we're going to talk about the quantum mechanical model. And for those of you in my course, we are not covering the wavelength frequency parts of this discussion, so you need to pick up with me on that first slide that I'm starting on. All right, so we're going to discuss the quantum mechanical theory. The reason we're not doing the other part of the chapter is because it is not something that we're supposed to cover. So we're taking out the things that we're really not supposed to do to give us more time for the things that are more important. So I'm going to talk a little bit about the history. Notice that I'm going to sort of put all these guys together. Okay, they are the pioneers of quantum mechanics and quantum chemistry, and they all provided a lot of the foundation. I'll mention them. You will know who they are and what they did, but it's not like you need to know what year or anything like that. You just need to know what their contributions were. So the early 20th century scientists realized that things were going on that they couldn't really see. And so they started trying to explain those things that were going on in that really small world and how it was different from the world that we lived in. And they laid the foundation for what we now understand as quantum mechanics and quantum theory. And they also defined better the subatomic particles of matter, the electrons, protons, and neutrons. What they discovered in their research was that the absolutely small, or that microscopic behavior, like the electrons and things like that, did not behave like the macroscopic world, the world that we were around, that Newton described very well and that follows, specific rules. This small world did not do that. It did not follow gravity rules. It did not follow any of those. And so subatomic particles appear to exist in a duality. That is, they behave like particles, like we would expect, but they also behave like energy. And so, and if you've ever seen a light wave, you may have seen this, okay, or any type of sine wave. That's a wave-like property, okay, and there are certain energy aspects associated with that. So in addition to behaving like a regular particle with mass and volume, they also have this energy part that sets them aside. And so we call this the wave matter duality concept, that matter behaves differently on this microscopic atomic level. And since these electrons specifically are very, very small, the number of electrons, for example, in a single speck of dust is higher than the number of people who have ever lived on Earth. I mean, it's just mind-boggling to try to figure out what that is or what it means or anything. But obviously we can't directly observe electrons very easily. It was impossible. We have been making progress in that, and if you Google observing electrons, you might see some interesting research in that area. But electrons are so small that actually the act of watching them or looking at them, observing them, changes their behavior. Even if you shine a light where you could see it, that's going to do something to that electron, because a light will excite an electron, okay, and it'll absorb that light and absorb that energy. So we've studied the electrons quite a bit because in chemical reactions, the electrons are what are going to be moving around. So what does the quantum mechanical model tell us? It explains that why these electrons exist and how they react. It is a light wave nature, that is energy, not the particulate, that defines the chemical and physical properties of the matter. So it's this energy part. We don't just look at it as, something orbiting the nucleus, like the planets orbit the sun. But we look at it as there is a cloud in 3 dimensions orbiting around that nucleus where you could find the electrons because they're moving all the time, and by the time you find it, it's gone again. So we look at that as a cloud, and that's what the quantum mechanical theory tries to help us understand. So it has provided a foundation for the periodic table and the trends, the behavior of elements when they bind together, and then the colors of atoms when they are reflecting light, and then their sizes. It predicts their atomic properties. So why some are metals and some are nonmetals, why some give up electrons whereas others gain, why some gain two instead of one, why some are very, very reactive, and then also these periodic properties that we're going to see in the periodic table. It explains that. And that is your introduction to quantum mechanical theory.